Welcome to our first lesson on Wise SCADA. In this lesson, we will create a small project and run it in Runtime. This screen will appear before you when Wise SCADA is first opened. We can click on Screen and add the objects we want here. We added a text box. And in its Value section, we selected the Now tag showing the computer time. When we click on Runtime, it asks if we want to save the project. We gave it a name and saved it. And we are waiting for Runtime to open. Runtime opened. We can see the computer's time live inside the text box. Now let's create a network that communicates with the PLC. I am selecting the most commonly used ModBus. When we click on the top ModBus TCP part in the ModBus interface, we need to write the PLC's IP address. Since we are working with simulation, we wrote the local IP address. We created a few tags by clicking on the New section to create tags. We can select the type of tags from here, or by entering the address directly. The type suitable for that address is selected automatically here. ModBus addresses in Wise SCADA also use the 6-digit structure. So we need to write the old address we wrote as 40,001 as 400,001. I am writing 3 addresses one after another. When I press the Connect part, we can see the communication data reading times here. The completion time of a cycle we see here appears as 114 milliseconds. So this is the reading time of the 3 tags here. If there are too many tags here, this time may increase. With the delay parameter here, we are actually slowing down this communication. When I entered the delay as 10 milliseconds and say connect again, we saw that the cycle dropped to 11 milliseconds. This is a very high speed. It is not possible for the operator to see or track values changing this fast on the screen. We need to slow it down by increasing the delay parameter here, according to our tag count and structure. Now let's show these tags we added on the screen. We can use the text box object again. From the Values section, from Tag Selection, we selected the Tag 1 label we just created. Let me copy the text box. Let me make 3 of them. Let me change the value of each one. I used a second text box to see the values we wrote, since we are in simulation. Yes, we are now communicating with the PLC. Now we have an address inside the PLC that changes constantly. I want to write that address. Address 4,011,025. It has a constantly changing value. We can follow it from here. And when we run the runtime, we can see from the screen that the value is constantly changing. As you can see, this is a constantly changing value inside the PLC. Now for the ModBus station we just created. Let's write some code to stop and restart it in Runtime. I added 3 tags from internal tags. I named this one Enable. Let the other be State and Connected. And let it be Fault. When we click on our network, and click on the Tags section here, let's select the Enable tag for this network's Enable. If this tag is true, the network will start working. When the network is connected, the tag we defined as connected will become true. When there is an error in the network, the fault tag will become true. Let's show these newly added tags in Screen Designer. I'm putting 3 checkboxes for this. In the first checkbox, I select Enable as the value. I will select Connected and Fault for the others. Now we run the runtime. Currently, connection with PLC is not established because we didn't set the enable bit. The moment we gave the enable, the connection with the PLC was established and the connected bit became 1. When we cut the enable, our connection was lost. What did we want to explain here? Starting and stopping communication with a device can be under the operator's control in runtime. To cause a fault, I am closing the simulator and when I try to connect again, the fault bit became set. I will restart the simulator while in fault state. The connection came automatically. We did the necessary operations to receive data from PLCs and show it on the screen for a simple project. There is only one thing left for you to know here. That is the database part. You can use 3 databases in Wise SCADA as MySQL, SQLite, and SQL Server. SQLite works over the file system without requiring any installation. We chose this one. Here, when it is first created, it creates the project by giving a database name. When we press the check button at the end, you can see the table structure inside the database here. Wise SCADA does database-related work automatically. But apart from this automatic process, you can intervene manually. For example, there are currently 2 columns in Table 1 where the data here is saved, named ID and timestamp. You can also add columns from here, or without dealing with this place at all, by clicking on the historical part where you created your PLC tags. You can ensure that the value of this tag is saved to the table. We have now made the necessary settings for the values of 2 tags to be saved to the table. At this stage, it still looks like 2 here. But when we run the runtime, those columns in that table were created automatically. And the values of 2 tags are being saved to the database. Now when we do check table, we will get a warning. It says that the configuration in the table and the configuration in the database are different, because it created these tags in runtime. And we accepted the table in the database as valid with the Save Database to SCADA button. Now our tags have come here. You can use many tables. You can create and add new tables. You can save tags to another table at the same time. Here, let's save our first tag to another table. And let the column name for the record in this table be Sally. When we run the runtime, this process will happen automatically. A column named Sally will be opened in the second table and data will be saved there. As you can see, a column named Sally was opened. And data is being saved to this Sally column. Regarding recording, currently with the recording period parameter, meaning we are recording every second. The recording time can also be changed. Faster recording or slower recording may be desired. Or recording can be performed by the triggering of another tag. For example, when the value of this tag is 12, a record will be made to this table. We have completed our first lesson. after a few more lessons like this where general features are explained. Our lessons where we will examine all features in detail will continue. We are expecting you to watch as well.